So one tool that you can use to help further with your forecast and look at relationships of data is a regression. So I'm going to add some data to this to demonstrate. So suppose we had cost of goods of the following amounts. In 2016 we have 1.5702 million, followed by 1695694 in 2017, 1992400 in 2018, 2.864 million in 2019, and in 2020 3.25 million. And you can go back and check the income statement and see that those numbers do line up and match. All right, so anytime you do a regression, at least in this we're just looking at two variables, we want to make sure that that regression we do actually, that relationship looks close to a line. So what I'm going to do is I'm going to highlight this data here, and I'm going to insert, can do a recommended chart, and in this particular case, let's do another scatter chart with the line. So this one looks good, and click OK. So you can see that is essentially a line. If you want to change the height and width with regards to this, you can, but we can clearly see in this case that that's a line. So how about the regression? Okay, so I could add the trend line, etc., but I want to demonstrate here another way of doing that. So we know that cost of goods sold, that's our dependent variable. They depend on the sales. So we make the sales, and that kind of determines what our cost of goods are. So we're going to create a function where we're going to have cost of goods is equal to some constant plus sales and then an error term to create a regression. So to do this, I'm going to go to data, and in my particular one, I'm not seeing regression. So I'm going to go to File, Options, Add-ins, Manage Excel Add-ins, and I'm going to add the Analysis Tool pack. Then click on Data Analysis. Scroll until you see Regression. Click OK. We'll input the Y range. So the Y range is cost of goods. The X range is the respective sales. I do have labels. With regards to this, anything else you want to check, we're going to want a new worksheet. We're going to call this Regression Results. If you want to add all these different plots, etc., you can. But for now, we're just going to do that and click OK. And now looking at our results and things that are meaningful. So typically you want your R squares to be pretty high. In this case, it's highly correlated. Another issue that we're going to necessarily discuss here. But R squared, the closer to 1 it is, typically the better, and or it's demonstrated that it's highly correlated. This F stat's pretty high and is very, very, very significant. Typically you want that number to be less than 0.05, which indeed it is. Looking at our coefficients, these are kind of the numbers in our model. So what we can say is cost of goods sold is equal to that intercept, or that number term, that negative 63,681 approximately, plus coefficient on sales is 0.86-ish or so. So I know it's 0.858264. You could pull that, but we'll just round it to 0.86 here, times sales. So that is our model or equation to forecast any cost of goods for this particular firm. Now, a couple other things to note. We're not really going to worry about the intercept t-stat, okay? We do want to ensure that the sales t-stat is very high, typically greater than 2, which it is. And the p-value needs to be less than 0.05, which it is, so that is good. Another check you can do is make sure that your coefficient, this is a range from a lower and upper 95%. Just make sure that 0 is not included in that. If it is, then your model is relatively meaningless. So everything checks out, and we are good to go using this model of cost of goods sold and sales. So that's a quick demonstration of our statistical significance.